Envelop for Life, the popular Ambisonics toolkit for Ableton Live, has been updated, and it's a big update, but it also causes some issues with things that we have done in the past. So let's talk about it. But first of all, hello everybody. In case you're new here, my name is Michael Wagner. I'm a digital media educator with more than 30 years of experience in higher education, and on this channel I talk about digital media, game design and spatial audio. Today about an Envelop for Life update. If any of those topics interest you, I invite you to subscribe or join our Discord community. Invite link is in the description below, or there's also a QR code here somewhere. And with that being said, let's get right to it. Now, first of all, what exactly is Envelop for Life? Now, if you've been a long viewer of my channel, you are familiar with it. Actually, my very first tutorial on this channel was about Envelop for Life, and I'm going to leave a link in the description, although the production quality of that tutorial is not as great, but it's still very valid, so you can still kind of watch that. But what Envelop for Life really is a set of Max for Life devices for Ableton Live that allow you to use Ambisonics audio within Ableton. You can download Envelop for Life for free by going to their website. They do ask you to sign up for an account, but that account is completely free, and once you're logged into that account, they give you a download link. However, if you don't want to make an account, you can also simply go to the GitHub repository directly and download it from there. Installation is very straightforward. All you really need to do is drop the Max for Life devices to wherever you have your Max for Life devices on your system, and you're ready to go. It does work for Windows as well as Mac OS. However, they do point out that some users have reported that it sometimes crashes on Windows. I personally never had those issues. I was working with it on Windows just fine. But if you are working in an environment where you need high stability, so for example, if you're using it for live performances, you might want to make sure that you are working with a Mac system in order to avoid any potential stability problems. So let's hop into Ableton and see what's new. Now I have Envelop for Life installed here in my user library under packs, and I have both the previous version as well as the current version. Now if you were working with Envelop for Life on a Mac operating system, you know that the previous version was not compatible with Apple Silicon. So in order to be able to use it, you had to switch Ableton into Rosetta mode, which is a bit of a drag because Ableton performs significantly better in native mode than it does in Rosetta mode. But just to demonstrate what happens if you would use it in native mode, you would essentially take one of the devices. Let me just take the master bus device here, for example, and let's put that on the audio track. And you would get an error. The error would tell you that this master bus device contains externals that are not compatible with Apple Silicon. Consider running live under Rosetta. And that was an issue. Now, the new version has fixed that. The new version is now finally compatible with Apple Silicon. So let's just change that out with the current version of the master bus device, and let's drop that here, and we have a perfectly fine master bus device. Now in this video I'm not going to talk too much about how Envelop for Life works in detail. I already did that in a number of other videos, and I'm going to leave some links in the description below. On a very basic level, what Envelop for Life does is it allows you to convert individual tracks into Ambisonics tracks and then route them through Max for Life into a master bus device that can sit on any track with the exception of the master track, interestingly. Now we already have the master bus device here, so all we really need to do is we need to put a panning device on one of the other tracks, and that will then essentially make the connection to a master bus device and send the signal directly through Max for Life from that track, converting that into Ambisonics into the master bus device that comes with Envelop for Life. So let's do that. So let's take this one MIDI track, for example, and let's take one of the panners. There are many panners that you can use, and I recommend reading the documentation for Envelop for Life. They have different purposes. What we are going to do here is we're going to simply use the source panner. That is one thing that I always do. That's the easiest panner. And once I put the source panner on a MIDI track, what is essentially happening is that the signal that is coming in here is here converted into an Ambisonics signal through a certain panning that I do. So I can essentially move this signal around here. And then it is routed through Max for Life directly into the master bus device. And it is arriving here at this master bus device. It is then decoded according to the decoder that I want to choose. In this particular case, I am choosing the binaural decoder. And then it is essentially sent out either through the output routing, or if I also want to monitor that, I can choose to monitor that on channels 1 and 2. And that is essentially the basic idea. So all I now need to do in order to complete that setup is add an instrument to the track that is routed into the Envelop for Life master bus device. So let's go to my track here, and let's maybe take an operator here, and let's maybe choose some piano here, and let's maybe do. I'm a little bit lazy today. Let's just kind of choose a preset here, and let's see if I'm getting something. I probably also need to put on my headphones, and if I'm now playing a note, I essentially hear everything. The signal comes from the instrument, goes into the source penner, is penned here, then reaches the master bus device, and here we see the individual Ambisonics channels coming in, and it is converted or decoded into binaural. And I'm monitoring that on channels 1 and 2. Those are the channels that are essentially reaching my headphone. Now, I can obviously kind of move that around now. So I can kind of move that to the left or to the right. I can also move that up or down. I can kind of change that in mono. And that's essentially what we're going to do, because it gives us a little bit more of an idea of where exactly the sound really is. So let me just set that back to where it was originally. So now it is in front of me, and I can move that to the left, to the right, sorry, or to the left. And I can move that up and down. And this encoder will turn that into Ambisonics, and then the decoder in the master bus device will decode that back into whatever channel-based format I want to have. Now, one of the things that we did in previous videos was that we chose a modified master bus device in order to enable head tracking. And unfortunately, because we now have a new master bus device that is capable of running in Apple Silicon mode, this previous master bus device no longer works. So if I'm going to my user library again, and I'm choosing this Envelop for Life master bus device for head tracking, which once again is a modified master bus device, it will essentially kind of tell me that this is now no longer capable of handling that, because once again that master bus device was based on the previous version of Envelop for Life and is therefore not Apple Silicon capable. I did reach out to the developer of the modified master bus device and asked him if he has any plans to update his device to work with the latest version of Envelop for Life, and he told me that yes, he has, and he's currently working on it. So do expect an update to this device pretty soon. However, some of you have reached out to me and asked me, is there any way to implement head tracking with the current state of Envelop for Life? And the answer to that is yes, there is. And this is what we're going to do first. Now, the way we're going to do that here is very similar to what we did last week in the Pro Tools tutorial. And back then we used a rotator device in order to mimic that head rotation. The idea was that we would rotate the sound field in the opposite direction of the head movement. So the idea essentially being that if you move your head to the left, for example, what you're really experiencing is a rotation of the sound field to the right. So if we rotate the sound field in the opposite direction of our head movements, we are going to get a realistic impression. And this, fortunately, can be done very efficiently with rotator plugins. That is something that Ambisonics is really good at, kind of rotating sound fields. And this is what we're going to do here. So first things first, I'm going to remove that device here that did not work. So let's just remove that. Let me just double check if everything is still kind of sounding okay. Yeah, still fine. And then what we're going to do is we're going to take a rotator device. And in Envelop for Life, this rotator device is called a higher order Ambisonics transform device. And we're going to put that into our signal chain. Now, there's one problem here, and that is a very unfortunate problem. And that is that technically what I would have to do is I would have to put that transform device in front of the master bus device. However, the Envelop for Life insists that the master bus device is the first device on the track, so we can't put it in here. Unfortunately, I also can't put it on any other track. I actually need to put that at the end of the individual track. So in other words, what we're going to do here is something that you would have to repeat for each individual track that you're using, which is a bit unfortunate, but it does work. So, kind of at least kind of from that perspective. So what we're going to do here, in order to make it work, we're going to take that higher order transform node. We're going to put that here on the individual track. It will now connect. And now if I'm playing that, the signal now goes through the source panel into the rotator plugin, from the rotator plugin into the master bus device. And you see sort of here everything going on. And if I change the yaw, essentially I essentially rotate the sound field around. So the last thing that I need is I need to somehow connect the head tracker to this yaw, pitch and roll information in this transform node. And once again, I would have to do that for each individual track, unfortunately. So maybe somebody from Envelop for Life listens to this and figures out a way on how to do that in such a way that they only have to do that once. But here I have to do this for each individual track. But however, what I need to do is I need to somehow take the information that is coming out of a head tracker, and I have to turn that into OSC messages that I can then read and map onto those yaw, pitch, and roll parameters. And for that purpose, I'm going to work with the Subway head tracker. Now, this is a head tracker that I use quite often and that also a lot of people recommend. It's also the one that is recommended by Dolby in case you want to use head tracking with the Dolby Atmos renderer. And for those of you who have seen me use this, you know that this is a little fiddly to kind of put on my headphones. So I'm going to disappear for a second and then essentially come back once that is on my head. And I'm back. I've now connected the head tracker to my headphones, and I've also cabled up and connected everything to my computer. So the next thing I need to do is I need to start up the Bridget application. The Bridget application is essentially responsible for taking in the messages that are coming out of the head tracker and converting those into OSC messages that we can then use within our computer. And that application comes with the head tracker, so you can simply download that from the website. Now, if I've connected everything correctly, I should already see my head moving, which is what I'm doing here. Let's just double check that everything is set up correctly in the head tracker setting. Make sure that you have the cable, the chirality set correctly. In my case, the cable is on the left, so this is correct. And the next thing I need to do is I need to make sure that the settings in the bridge settings are correct. Now, I can technically use any profile that I want because I will need a separate device that can take in these OSC parameters and convert that into something that it can use in Ableton. I will actually have to kind of do the conversion manually. So I could technically use whatever profile I want. However, I strongly recommend using the Sparta profile because that is the one that works best. We just take note that the messages that are sent out, the OSC messages, have the message header YPR for yaw, pitch, and roll. We're going to get your yaw, pitch, and roll information in one message, and we are going to send that out under port 9000. That's sort of the settings that we have here. So let me just put that out of the way. So the last thing I need to do is I need to make sure that these messages are received by Ableton and then fed into this transform. And for that, I'm going to use a device that I've used actually quite often. That is the OSC input device. Now, unfortunately, that OSC input device is no longer really officially available, so the developer website has disappeared. However, if you want to use that particular device, you can download that from our Discord server. I'm going to put links in the description below, and I'm also going to put the QR code here up once again. So you can go over to our Discord server, and under the forum that is called Supplementary Material, you can download that device, but it's a very simple device. And we're going to drop that on our track. And once again, we unfortunately have to do that for every track that we're mapping, but I only have one here, so let's drop that here. And I have let me just kind of move that over here. I now here have all the information that I need to put in. First things, the head tracker is sending out at port 9000, so let me just switch it over to 9000. 9000, and then the path that the head tracker is sending out is YPR. As soon as I do that, I already see the messages coming in. So kind of the long field here is the full message, which is yaw, pitch, and roll information. And then here we have the one kind of argument that is taken out, which is argument number 0, so the first one, which is the yaw information, and we can then map that. This is what we're going to do next. But before we do that, let me just complete that. YPR, we need the pitch information, and the third one, YPR, we need the roll information. Pitch information is the parameter with argument number 1, which essentially means it's the second one, and the roll information is the one with number 2, which is the third one. And I now have yaw, pitch, and roll information here. Now, the next thing I need to do is I need to map the parameters that are coming out of the OSC input plugin, and I need to map them onto the higher order Ambisonics transform device. And for that, first, let me kind of make that maybe a little bit smaller so that we see everything. Essentially, here we have the input device, we have the source banner, we have the higher order Ambisonics transform, we have the Bridget application. Now, the transform device expects yaw, pitch, and roll values from -180 degrees to +180 degrees. And so we also need to make sure that the settings here in minimum and maximum settings are set correctly. So here we have from -180 to +180. And we're doing the same thing for the pitch. Now, the pitch technically is only recorded or reported from values in values from -90 to +90. However, since the transform device expects it from -180 to 180, it would not send the correct information to the transform device if we would set it from -90 to +90 here. And then the last thing is we need to map. So let's map that one to the yaw. Let's map the second one to the pitch, and let's map the third one to the roll. And once again, unfortunately, you have to do that for every single track because the higher order Ambisonics transform device has to sit on that track that essentially generates the Ambisonics audio. So let me recenter that, and then essentially I see the yaw, pitch, and roll information. Everything is coming in. Now, one final thing, I need to make sure that the orientation is correct. You remember that I said that we actually need to rotate the sound field in the opposite direction of the actual head rotation. However, in the way the Sparta preferences in Bridgehead are set up, this is already happening. So it is already reporting the data in exactly the direction that we need. If you, for example, would hear it in the wrong direction, so for example, if you're moving your head to the left and the sound field is not rotating to the right, but it's actually rotating into the right, kind of moving the object even further to the left, what you would need to do is you would need to simply set the minimum and maximum settings here from 0 to 100 in the opposite direction, so from 100% to 0%, and that would essentially turn the orientation around. But in our particular case, if you use the Sparta settings in Bridgehead, that is already taken care of. And then let's see if I am essentially hearing something. Let me just recenter again. And I'm probably going to get a better impression if I'm switching that to mono. So I'm having it to the right, and if I'm rotating the head to the right, you will actually hear that as something that moves on your speakers to the left. So that is actually working. So let me just kind of maybe do something that's a little bit more interesting here. So let me just remove that instrument, and let's do something, an instrument. I like tune. Tune is good. Let me just kind of recenter that again. And obviously I can now also kind of change the position of that sound source. So it's now behind me. I can also kind of move it upwards. So it's now on top of me. And that works just fine. Once again, with the one caveat that you actually need to set that up for each and every single Ambisonics track that you're routing into the master bus. Unfortunately, you can't set that up on the master bus because the master bus device insists on being the first device on the track that it sits on. Now, there's one additional thing that I wanted to just show, and that is that the modified master bus device had one additional feature that was nice, and that was that you could route the audio not only into outputs, but you can also route that into tracks in your Ableton session, and the idea obviously being that you could then essentially record everything through Ableton. Now, with the recent version of Envelop for Live, they also included such a feature in Envelop for Live, and the way this works in Envelop for Live is that you have to use let me just go back to the Envelop for Live here. You have to use this export utility. Here we have it, export utility. So if I'm putting that on my track, what it allows me to do is it allows me to set up a system where the audio from the Envelop for Live master bus is then essentially routed to individual tracks in my Ableton session. One application would be, for example, that if I want to, for example, I want to record a 7.1.4 render. So I'm switching that to 7.1.4. I'm also turning off monitoring because I don't really want to hear the first two channels twice. What I can then do is I can essentially say I want to export 12 channels, 7.1.4, those are 12 channels. So let's select 12 here and let's create tracks. And what that will do is it will create 6 tracks for the 12 channels, 1, 2, 3, 4, 5, 6, and it will allow me, or it will send the audio to those 6 channels. Now, I'm currently not hearing anything because it's not really kind of going to the output, but you can see that these 6 channels are now receiving the 7.1.4 downmix of the Ambisonics signal. And that essentially means that I can do things that I couldn't really do before. One thing that I can do, for example, is, and that was an issue in that I showed in one of the videos where I used Ableton in connection with Dolby Atmos, where we kind of used Ableton in order to create a Dolby Atmos bed. We said that, unfortunately, the way Envelop for Life is set up, or the decoders in Envelop for Life are set up, we can't really make any changes to the LFE channel. We now can actually do that because the LFE channel is channel number 4. So if we want to just kind of make changes to the LFE channel, all we really would need to do is we need to take an EQ, set it on the channel that, or on the track that holds the LFE channel. The LFE channel is the channel number 4, which is the right channel on that particular track. So we can set that to stereo mode, to left-right mode, sorry, and then essentially simply say I want to, this was the right channel is the LFE channel, I want to simply have a low-pass filter. And that then allows me to essentially implement a low-pass filter for the LFE channel by going through the export that Envelop for Life provides. And in the very same way, another thing that we can do, for example, which was also an issue that we ran into when we worked with Dolby Atmos, and that was that the Dolby Atmos bed by default is a 7.1.2 bed. And here we have a 7.1.4 downmix. So essentially we have 4 overhead speakers. And one thing that people usually do is, in order to get the full immersive impression of such a bed, they turn these 4 overhead speakers into objects. And because we now have these channels individually, we could technically route them into kind of route the first 8 into the object bed, and then the remaining 4 overhead we could route into objects, and then essentially do the very same trick that is also used by something like Fiedler Audio's Dolby Atmos Composer with their composites, or also with the latest version of Pro Tools, where they have these templates where you can essentially route the overhead channels into individual objects. We can do the same thing here in Ableton as well. If you want me to show how that actually works, let me know. I can do a video about that. But in principle, this is actually fairly straightforward. You just kind of use them as objects and then essentially position them accordingly to where you would normally search for the overhead speakers, and then essentially send everything to the Dolby Atmos renderer. So this is really everything I wanted to say today. Thanks again for watching. As you see, this is a really nice update to Envelop for Life. We could do everything that we used to do with the modified device, with the one caveat that we needed to do the head tracking for each individual track and not as in one go in the master track. But maybe somebody out there can find a solution how to do that. And otherwise, if you have any questions or comments, please use the comment section below or join us in our Discord community. Invite link once again in the description below. And with that being said, see you at the next video.